Vitamin D might just be the most misunderstood nutrient in the entire wellness conversation. And yet, it shows up everywhere in supplement aisles, in doctors' offices, in late night health forums where people are convinced it's either the answer to everything or completely overhyped. Dr. Lena has seen this firsthand, and the truth is actually far more fascinating than either extreme suggests, because vitamin D isn't just a simple nutrient you eat and absorb, it goes on a full biochemical journey through your body before it ever does anything useful, and understanding that journey completely changes how you think about your health. So today we're going to break down exactly what happens from the moment sunlight touches your skin to the point where vitamin D finally activates inside your kidneys, what it actually does once it's active, who genuinely needs to worry about being low, and whether popping a daily supplement is smart, wasteful, or somewhere in between. And yes, there's a reason vitamin D behaves more like a hormone than a classic vitamin. And once you understand why, a lot of things start clicking into place. Let's start with what's actually happening in your skin when you step outside on a sunny day, because this part tends to surprise people. Deep within the outer layer of your skin, the epidermis, there lives a cholesterol-based compound called 7-dehydrocholesterol, and this molecule is essentially vitamin D in waiting. When UVB rays from sunlight penetrate the epidermis and make contact with that compound, a photochemical reaction occurs, and 7-dehydrocholesterol gets converted into vitamin D3, also called cholecalciferol. It's genuinely remarkable. Your body is using light as a biological tool to manufacture a compound it critically needs. But here's where most people's understanding stops and where the story gets really interesting, because that vitamin D3 you just made in your skin is not the active version yet. It's more like an unfinished product that still needs to be processed in two completely separate organs before it can actually do its job. That vitamin D3 enters your bloodstream and travels to the liver, where enzymes convert it into a compound called 25-hydroxycholecalciferol, sometimes written as 25-OHD. Now, this form is important for a specific reason. It's the primary circulating form of vitamin D in your blood, meaning it hangs around long enough to give doctors a meaningful snapshot of your overall vitamin D status, which is exactly why this is what gets measured on standard blood panels when your physician checks your vitamin D levels. But even at this stage, the molecule still isn't fully active. It travels from the liver through the bloodstream and eventually reaches the kidneys. And this is where the final and most critical conversion happens. Inside the outer portion of the kidney, in tiny tubular structures called proximal convoluted tubules, a hormone called parathyroid hormone sends a signal that triggers the conversion of that 25-hydroxycholecalciferol into 1,25-dihydroxycholecalciferol. And this is it, the fully activated form of vitamin D, sometimes called calcitriol. Now, why is parathyroid hormone the one giving the green light here? Because the parathyroid glands, which are 4 tiny structures attached to the back of your thyroid in your neck, are constantly monitoring calcium levels in your bloodstream. When calcium dips, parathyroid hormone surges, and one of its immediate responses is to activate more vitamin D, because one of the most essential and well-established jobs of activated vitamin D is to dramatically increase calcium absorption in your small intestine. Without adequate activated vitamin D, your intestinal cells can only passively absorb a small fraction of the calcium moving through your digestive tract. But when 1,25-dihydroxycholecalciferol is present, it binds to receptors on intestinal cells and stimulates them to produce more calcium-binding proteins, essentially creating more docking stations for calcium, so far more of it gets pulled into the bloodstream. This is why calcium and vitamin D are almost always mentioned together in the context of bone health. They are biochemically inseparable. If you're chronically low in vitamin D, your body can't absorb enough calcium from food, and when blood calcium drops too low, your body doesn't just accept that outcome. It starts pulling calcium out of your bones to keep blood levels stable, because calcium is too critical to nerve signaling and muscle contraction to let it fall. Do that long enough, and you end up with weakened, brittle bones, increased fracture risk, osteoporosis, and a painful condition called osteomalacia in adults, which involves a softening of bone tissue. In children, severe deficiency produces rickets, a condition that can cause visible skeletal deformities and impaired growth. Beyond bone health, the reason vitamin D has captured so much research attention is that receptors for its activated form have been identified in an enormous variety of tissues throughout the body, including immune cells, muscle tissue, brain cells, and even certain hormone-producing glands. This receptor distribution has led scientists to investigate whether vitamin D plays a role in immune regulation and inflammation, whether it influences mood and cognitive function, whether it has any relationship with testosterone and other hormones, and whether it affects the behavior of certain cancer cells in laboratory settings. These are genuinely intriguing areas of ongoing research, and while the science is not yet at the point where sweeping clinical claims are justified, the breadth of tissues expressing vitamin D receptors tells you that this molecule likely has a much wider biological footprint than just bones and calcium. Now, here's the part that confuses a lot of people. Vitamin D deficiency is remarkably common, and yet the majority of people who have it have no idea, because mild to moderate deficiency often produces no obvious symptoms at all. When symptoms do appear, they tend to be vague: fatigue, muscle aches, a general sense of not feeling well. The kind of thing that could point to a dozen different conditions, which is part of why testing matters more than symptom guessing. Whether you're personally at risk depends on a surprisingly long list of factors: how far north you live and how much winter sun you actually get, how much time you spend outdoors, your age, since the skin becomes less efficient at synthesizing vitamin D as you get older, your skin tone, since higher melanin concentration reduces UVB penetration into the epidermis, meaning people with darker complexions need significantly more sun exposure to produce equivalent amounts of vitamin D3, your dietary habits, and even your body composition, since vitamin D is fat-soluble and can become sequestered in adipose tissue, making it less bioavailable. Because of all this variability, blanket statements like "everyone is deficient" are an overreach, but so is dismissing low vitamin D as a non-issue. The reality is that insufficiency is common enough that awareness and occasional testing make sense for many adults. When deficiency is confirmed through blood testing, the response depends on its severity and cause. Some people can address it through more frequent sun exposure or dietary changes, while others require supplementation, sometimes at meaningful doses. For those who want a more proactive approach without definitive testing, a modest daily supplement in the range of 1,000 to 2,000 IU is broadly considered safe for most healthy adults. And while vitamin D toxicity is technically possible given that it's a fat-soluble vitamin that accumulates in the body, it is genuinely rare and typically only occurs with sustained, very high doses far beyond that maintenance range. The honest trade-off with supplementing without testing is that you're operating without a baseline, so you won't know whether it's correcting a real shortfall or adding to levels that were already fine. But for many people, the low risk and potential benefit of a moderate daily dose makes it a reasonable personal choice. What's not reasonable is assuming that vitamin D supplements are a cure-all, because the science just doesn't support that, or that deficiency is irrelevant, because decades of research on calcium metabolism, bone physiology, and the sheer ubiquity of vitamin D receptors throughout human tissue tell a very different story.